For those of you that are fast forwarding through my videos, what I'm going to do is I'll write the problem numbers up on top because I'll put multiple videos together for certain problems depending on the length, and that way you can skip forward, and when you see a new problem number up top, that'll tell you to go ahead and pause so that you can check your answer. Okay, so here's problem number 1. The idea is we need to convert the angular measure of 82.4 degrees into a measure in degrees, minutes, seconds. So I have 82.4 degrees, and I need to go to degrees, minutes, seconds. So what I'm going to do is I'll get the degree value first, and that's the easy one to grab, because that's whatever's out in front of your, to the left side of your decimal place. So that'd be 82. So that's my degrees. Now the minutes is going to come from the 0.4. So what I'll do is I'll do the conversion there. It's 0.4 degrees. I'll multiply that by something over degrees. So there are 60 minutes in 1 degree. So 0.4 times 60 is going to give us 24. Okay, so 0.4 times 60, 24. 0.0, there's nothing left there. Okay, so 24, and this is in minutes. So I've got 24 minutes. If I had more of a decimal place, I would multiply that value again by seconds. Okay, so let's say I had, for example, I had 24.3. Well, then I would take the 0.3 and multiply it by 60 again to convert it into seconds. But I don't here. So there's 0 seconds. And that's my solution. Okay, let's take a look at the next one. Okay, for this one, we've got to work in reverse. We've got 120 degrees, 24 minutes, and 40 seconds. To convert that back into what we call decimal degrees, we're going to take the 120 plus, now I'm going to take the 4 here, the 24, divided by 60. I'm going to add to it 40 divided by 60 times 60, which is 3,600. So this is really 120 plus 24 over 60 plus 40 over 3,600. So just grab our calculator. So we've got 120 plus 24 divided by 60 plus 40 divided by 3,600. So that gives me 121.41 repeating degrees. And there's your solution. Oh, excuse me, not 121, 120. There we go. Okay, let's take a look at the next problem. So we need to convert 9 pi over 16 radians into a degree measure. So 9 pi over 16. To convert that, we need to multiply it by radians on the bottom and degrees on the top, because then our radians will cancel out. Remember that pi is not part of the radians. Pi is a number. So we know that we've got 180 degrees for every pi. So what cancels out here? Well, the pi's cancel out, the radian values cancel out because this is in radians. Okay, I could have written this, let me write it like this for you. Really, the whole idea what's going on here is I've got 9 pi over 16 radians. I'm going to multiply that by 180 degrees over pi radians. Now the pieces that cancel are the pi's, the radians, so we're left with our measurement being in degrees. So this is going to be 9 times 180. That's going to be degrees over 16. So we can do some reducing first, but we'll just grab our calculator. So 9 times 180, okay, divided by 16, so 101.25 degrees. Just like that. Okay, let's take a look at the next one. Okay, so this is going to be problem number 4. So I need to convert 2 radians into degrees. So 2 radians into degrees. So I'm going to multiply it by, I need radians on the bottom again. And I need degrees on top. Now notice that the pi's don't cancel out here because there's no pi on top. So what I need to do on my calculator is approximate pi with 3.14. So this is going to be 360 degrees because 2 times 180 is 360 over pi, which is 3.14. So I'm going to take 360 and I'm going to divide that by 3.14. So I got about 114, we'll say 0.65 degrees. Okay. So just remember that this thing right here is just a number. Okay, let's go ahead and take a look at problem number 5 now. So we need to let beta be equal to pi over 3. And we need to find the complement and the supplement. So the complement is if the two angles, so beta plus whatever the complement, I'm going to call it C, that's going to be equal to 180 degrees, which is the same thing. Excuse me, not 180, 90. We'll edit that. Okay. So these guys have got to add it to be 90 degrees, which is pi over 2. So to find the complement, I'm going to take 90 degrees, subtract beta, and that'll be the complement. So we'll get a common denominator here. So this is 3 pi over 6 minus 2 pi over 6. And that gives me just pi over 6. So there's my complement. The supplement is if they add up to be 180. So essentially the beta value plus the supplement has to be 180 degrees. And we know that that is pi. So what we want is pi minus pi over 3 has to be equal to the supplement. So if we take 180 minus our angle, we'll get the supplement of that angle. So this is going to be 3 pi over 3 minus pi over 3, and that'll give us 2 pi over 3. So those are our two solutions. Okay, let's go on to problem number 6. For problem number 6, we're going to let theta be equal to pi over 6. And we're going to find the least positive and negative angles that are coterminal with theta. So what that means is we have an angle. Okay, there it is, pi over 6. And I need an angle that's coterminal, meaning that it ends in the same spot. So to get a positive one, what I'm going to do is I'm going to take pi over 6 and I'm going to add 180 degrees, 360 degrees to it. So for the positive coterminal, I'm going to take pi over 6 and I'm going to add 1 revolution, which is 2 pi. So that's pi over 6 plus 12 pi's over 6, or 13 pi over 6. Now to find the one that's negative, I'm going to go the reverse way. So I'm going to go from my angle, I just want the positive way, I'm going to go the reverse. So the negative angle goes this way, so we want to subtract 360 from it. So pi over 6 minus 360, which is minus 2 pi. So that's pi over 6 minus 12 pi over 6, which is negative 11 pi over 6. And those are your two angles that are coterminal with our theta value. Okay, number 7. I've just noticed I'm running out of colors. Let's go back to let's go to orange. For problem number 7, I need to find all angles that are coterminal with pi over 4. So if we draw that out, this angle is pi over 4. Now I need every angle that stops at that angle. So I need every possible revolution. So what I'm going to do is I'm going to take pi over 4 and I'm going to add to it revolutions, which are 2 pi. So to add and subtract revolutions, I'll just multiply this by a number, which we'll call k, where k is an integer. So as long as k is an integer, then I start getting revolutions of 2 pi. And that's your solution there. Okay, problem number 8. You got a merry-go-round. It's got a radius of 4 feet. If it spins 2 times every 5 seconds, what's its linear speed in miles per hour? So let's draw out a picture of our merry-go-round. Here it is. And its radius value, this length from the center out, is 4 feet. In fact, we really don't need these. Okay, but its distance out right here is 4 feet. So the question is well, how far around is it? Okay, what's the circumference? So here's how we're going to do this. One revolution, that's the circumference. One revolution around the circumference, and that is equal to 2 times pi times the radius, which is going to be 2 times pi times 4, which is 8 pi feet. So in one revolution around, we cover 8 pi feet. So I'm going to write that. So in one revolution, so I go 8 pi feet in one revolution. That's my ratio. Okay, so if I multiply the bottom by 2, then I multiply the top by 2. Okay, and that gives me 2 revolutions, or how much distance I travel in 2 revolutions. Now I need to convert that into miles per hour. Now, but remember, this thing spins 2 times every 5 seconds. So in one revolution, so to do one revolution, it takes me how long? Well, if it spins 2 times every 5 seconds, then to spin 1 time, it must take me 2.5 seconds. So it does one revolution every 2.5 seconds. So now what we're going to do is we're going to cancel out our revolutions. And so now we know how many feet it does per second. But we want this in miles per hour. So I need miles on the top. So what I'm going to do is I know that there's 5,280 feet in 1 mile. And now my feet cancel out. So now I got miles per second. Now I need to get that in hours. So on the top, there are 60 seconds in 1 minute. And there are 60 minutes in 1 hour. And so now my seconds cancel out, and my minutes cancel out. And my units on top are miles, and on the bottom is in hours. So we just need to multiply straight across. And so let's go ahead and take, this is 8 times pi times 60 times 60. So that's 90,432. And that's miles per. Now on the bottom, that's going to be 2.5 times 5,280 is 13,200 hours. Whoops. Let's take this back. There we go. Okay, so now we need to take the 90,432 and divide that by 13,200. And we're going to get 6.851. So we're traveling at about 7 miles per hour.